Hi, and welcome to this short video on solids, liquids and gases. You probably already know that a substance can exist as a solid, a liquid or a gas. We call these states of matter. The particles in a solid, such as ice, are packed closely in a regular structure and are held together by strong bonds or forces. For this reason, it can be quite difficult to change the shape of a solid. Overall, the particles can't move from one place to another, but they vibrate about their fixed positions. The particles in a liquid, such as water, are spaced out a little more than they are in a solid, but they're still packed quite closely, which means that a liquid can be very difficult to compress. The bonds are weaker than in a solid, and for this reason, the particles in a liquid can move around one another. This means that liquids can flow, and can fill the bottom of any container which they're placed into. The particles in a gas are separated by quite large distances, and there are very weak forces of attraction between them. As you can see by this diagram, these particles undergo constant random motion, which helps explain why a gas can expand to fill any volume. One last word on these three states of matter before we go on. As you can see from the particle spacing, in general, solids tend to be more dense than liquids, which are in turn more dense than gases. Moving on now. A system of particles, which is really just a fancier way of saying a collection of particles, will always store energy as long as its temperature is above absolute zero. This energy can be split into two types: kinetic energy and potential energy. The internal energy of a system is the total amount of kinetic and potential energy of the particles it contains. It's easy enough to see why a system has kinetic energy, as even the particles in a solid are constantly moving a little as they vibrate about their fixed positions. But what do we mean by the potential energy of a system? We mentioned earlier that there are forces between the particles that make up a system. These forces are strong in solids, a little weaker in liquids, and very weak in gases. Let's have a think about the bonds that hold a solid together. These act a bit like the springs holding these balls together. When the middle ball is held to one side, the potential energy of this system increases in the same way that potential energy is stored in a stretched elastic band. When we release the ball, this stored potential energy is converted into kinetic energy as it moves back to its original position. When we change the internal energy of a system, a substance can change from one state to another. When enough heat is supplied to a solid, it'll undergo melting and be converted into a liquid. Similarly, when enough energy is supplied to a liquid, it can turn into a gas. Note here that evaporation and boiling aren't exactly the same thing. A liquid can evaporate at any temperature. Think about a puddle apparently disappearing from the pavement, but boiling only occurs at a substance's boiling point, which is 100 degrees Celsius for water at standard atmospheric pressure. The direct change of state from solid to gas, which we call sublimation, is less common. Dry ice, which is just solid carbon dioxide, will undergo sublimation when left out on a bench, and we're familiar with the way in which during the winter, snow sometimes seems to disappear from the ground, and ice from car windscreens. In both cases, water is undergoing a direct change from a solid to a gas. All three of these changes of state involve increasing the internal energy of the system. Going in the opposite direction, when we decrease the internal energy of a gas, at a certain point it will condense to form a liquid, and likewise, decreasing the internal energy of a liquid can cause it to freeze and become a solid. A change of state is an example of a physical change. When a substance undergoes any one of the above processes, no new substances are formed, and the change can be easily reversed by changing the internal energy of the system through the addition or removal of heat energy. Note also that mass is conserved in all of these processes. If we boil 1 kilogram of water, for example, then we'll end up with 1 kilogram of steam, because we haven't added or taken away any water molecules in doing so. That brings us to the end of this video on solids, liquids and gases. So hopefully you're solid on your liquids and gases now. And your solids too, of course. Thanks for watching and call back soon.